Hello. As many of you know, I came a long way and quite jet lagging at the moment. So if my brain flips a few bits during this talk, I apologize in advance. So Mocl. The title of this talk is Creating iOS and Android Apps in Lisp with Mocl. My name is Wes Henderson. I am the founder of Bluecakes and the creator of Mocl. So just a little preview. This is a Lisp mobile app made with Mocl. We'll talk more about that in a second. So first off, just mobile in general. As many of you have probably heard, mobile is taking off like a rocket. On the other hand, PC is basically flat. This is true whether you look at devices sold quantity-wise, or bandwidth usage, or customer counts, or basically by every metric, mobile is going up and up. According to Morgan Stanley, we are on the 5th computer technology cycle. It began with mainframes, then went to mini computers, then the desktop PC, then desktop PC with internet, and now mobile. And it's looking like possibly we're on to another generation soon with wearable devices. So pretty exciting. So as with any change, there are significant challenges. In the case of mobile, 10-foot screen sizes, the hardware itself is slower. We're seeing a variety of mobile platforms, which makes it harder to develop for. And the App Store distribution model is changing how apps are being sold. So I believe Common Lisp has some very significant, unique advantages in pursuing mobile. High performance, portability, and reduced dependence on other languages. So high level and fast. You could go with Ruby. Ruby's high level. But an argument is that it's slow, to which the counter-argument is, well, for most web applications, that doesn't matter, which is a fair defense. However, in the mobile space, not only is hardware slower, but a lot of times you want to do more intensive things. So you have a lot of sensors that could pull data, accelerometer input, GPS, camera, and mobile apps themselves are often more graphics intensive. People are doing very interesting things with them. Another aspect I think Common Lisp has unique to mobile is that there's a strong culture of portability. So there is no one dominant Common Lisp implementation, and we sort of accept and expect to be able to migrate our code, which in a world where you are targeting a variety of types of devices is very significant. If you have a mobile app, very often you will also have a desktop app or a web app to go along with that. And our flexibility in being able to target these different platforms, I think, is a huge advantage. I also want to say, it's sort of been said that specs are obsolete, that in the internet era, we have the benevolent dictator model, and specs are irrelevant. But for me, as an implementer, it's huge. Having the already established culture of these different Lisp implementations made it much more accessible. And I think every common Lisp programmer gets the benefit of that. So, one more plus. And then the other thing I wanted to mention is that you tend to see more pure common Lisp code. In other languages, very often just wrap C libraries or what have you. I think partly this must be due to performance. You don't have to jump out of common Lisp as often. But the benefit here, it's kind of a pain enough to build any given C library, but in the case of mobile, a lot of the libraries out there have not even been tested, so not only is the configure script broken, but it was just never even designed for a mobile app. So our ability there to just have pure common Lisp code is quite convenient. So, Mocl. For all of those reasons and more, I started working on Mocl a couple of years ago full time. This is just sort of my personal project. So what it actually is, it's a common Lisp to C compiler. So it gives you fully native code. There's no interpreter there. It's trying to do most of ANSI at this point, although that's a pretty tall order, being so huge spec-wise. And it's fairly sophisticated, which is really one of the strengths of common Lisp. We've come to expect our common Lisp tools to have a lot of sophisticated features such as type inference, and Mocl tries to live up to that standard. Quick diversion. So many of us have seen a computer that looks like this. Maybe it's not your computer, but a family member's computer or someone you know. And one way of looking at this is that the user was dumb and didn't know what they were doing. And that's one view. And another view is just that it's a design flaw and that the computer could be designed better. And that's sort of the approach that Apple is taking with iOS. So there are significant security features there that impact how we create mobile apps. And I'm sure you've heard about this, these sort of draconian Byzantine app store. One of the major things they do, every app is signed, cryptographically signed. And if you think about this, if your app was signed but then could change after you signed it, that would be sort of a loophole in the whole model. Policy-wise and technology-wise, Apple has tried to restrict this from happening. And if you're familiar with the processor feature called no execute, basically Apple has taken it to a totally strict mode where all apps are in no execute all the time. Once memory is writable, it cannot become executable. And the upshot of that is you can't do a JIT, a just-in-time compiler in the vein of Java or something like that. And you can't really do the fancy runtime redefinition if we're talking about native code. On the other hand, one possible sort of loophole in all this is interpreters. Because interpreters not running true machine code, the checks just don't catch that. And because of this and possibly other reasons, Apple initially banned interpreters. That has since been loosened up, and there are rules around, well, the code must be predefined. You can't be generating it at runtime. So the upshot of this is Mocl and several other iOS targeting tools compile everything ahead of time to make sure that you don't get rejected out of the App Store. So that's been part of our focus, is just to make sure that everything's going to comply with their policies and so on. Another thing I want to talk about with the App Store model, it changes how we view licensing. So the App Store has its own set of red tape, and really when I say the App Store, think of it as any vendor. I mean, Apple is one of the biggest in terms of economic impact right now, but it really could be any vendor. And so their policies conflict in some cases with open source licenses. In fact, the Microsoft Store, my understanding is it bans copyleft licenses entirely. So something to think about if you're going to make mobile apps, whether you use Mocl or not, something to be on top of. So my goal with Mocl is sort of it just works. Wanted to make it as convenient as possible to use. So as I mentioned earlier, going for most of ANSI. It also has Unicode strings, which are handled automatically. You don't need to think about it too much. Gray screens, networking in the form of usocket, TCP/IP, and several libraries. So on one side we've got Drachma, PPCRE, CLWho from our organizer Eddie. Those are all working. Zectines, Vecto, Vectometry, Zping, Salza, several things on Zach's side. Hans's Yason. So those are just a few. I've tried to make it as compatible as possible. And as I mentioned, pretty sophisticated stuff on the compiler side. So type inference, type declarations, optimized arithmetic, typed arrays, tail calls, dead code elimination. I've assembled an FAQ from questions I got at dinner last night. Although it was really breakfast for me because I had just woken up for that. First of all, why not Clojure? So partly for the reasons I just talked about, portability and so on, I thought was significant. I was concerned that Clojure libraries might be too Java dependent. Also just the JVM orientation of Clojure in general didn't seem like a good fit. Also just having a spec, this is not new territory for Common Lisp. We have several implementations, and you know, this is from the point of view of an implementer, an easier, safer path in a way. Why not an existing Common Lisp? So a couple reasons. One, on the licensing side, I wanted maximum flexibility with respect to app stores, so that narrowed it down somewhat. And also, there are some unique aspects of the problem domain itself, the security model being one, and just the overall workflow of having one computer to develop on, which then targets another computer as the actual runtime environment. Why not something easier to implement, like Scheme? That actually was probably a good idea. If I had known at the time that Common Lisp is as big as it is, not sure what I would have done. But here I am now, so it's kind of too late. So let's make an app. So the first thing within Mocl, you need to create sort of an empty project in Xcode or the Android developer tools. This serves as sort of the skeleton of the application. I've got a simple function here, hello world kind of thing. So it's just takes a single argument called name and prints the standard out hello name. So exposing this into iOS or Android, I have a little declaration here identifying it as a call-in. And you'll notice there is a little specified. I didn't put what type the argument is. I didn't say what the return type is. And I've tried very hard to make Mocl as convenient as possible with this kind of stuff, so there's a minimum of boilerplate. If you don't need to specify it, you don't have to. And so this function actually, if you passed it, so you'll be calling it from Java or Objective-C. If you passed it a string, it would work with that. If you passed it an integer, it would work with that. If you passed it a float, it would work with that. So if we just save that to a file, hello Lisp, we could then invoke Mocl at the command line. Just takes an argument of a target directory and the file that you want to compile. Once we've done that and hooked it into our Xcode project or Android project as it may be, that function is exposed as a C or Java function. As you can see, you're getting completion on the function name and also the argument names of that function. And we run it there. Hello, ECLM. So just a quick fun fact. On iOS, standard out works great. It's a little disappointing with Android. It's supposed to be Linux, but by default, standard out and standard error are directed to dev null. And if you want to print stuff out, you have to use a Java logging framework. So this is the contacts app I showed earlier. So there it is on an iPhone 4 and a Nexus 4. It runs very similarly on both, and you notice I've tried to give it a similar look and feel while still maintaining sort of the native mobile interface that belongs to that platform, or belongs to each platform. Have sort of the inertial scrolling and rotation. So what was happening right there, Zacting's vecto or vectometry renders the list and hands it off to the mobile framework of each platform. On the data side, it's just sort of simple Lisp calls to, say, sort the list, or I save it to a Lisp file, serialized out with the Lisp printer or the Lisp reader. The user interface stuff itself are sort of the stock platform components. So navigation, form fields, and scrolling, that's all iOS or Android. And in the future, I'd like to throw in Drachma and do some kind of server communication. But that just kind of gives you an idea of what you could do, how the app could break down. So it's not 100% Lisp, that's kind of the dream. But realistically, just as you might, if you're making a web app, you'd have Lisp on the server side, but you'd still have to do some HTML and JavaScript. It still has some Objective-C or Java to control the user interface and so on. So let's talk about debugging. It may all sound nice, but how are you actually going to figure out errors and so on? So I have a function foo. It indexes into an array of size 3. And I have a function bar, which just calls foo. So suppose that I call bar with an argument of 9, which is well out of bounds. On the iOS side, I would get a stack trace, a Lisp stack trace, with line numbers, pointing out, which function failed and where you can find that. And same on the Android side, it throws a full-blown Java exception, starting from the Java calls and then going into the Lisp calls. So, when will Mocl be available? I've pondered on this very deeply, and the answer is Lisp Universal Time 3,581,000,000 even, or 3 weeks from today.
Under terms, or?
Yeah. So I have Mocl's proprietary license. I'm trying not to be too restrictive about it. And if you want to buy the source code, you can do that. So that's kind of the philosophy. And if you'd like to see it right away, can't wait, just send me an email at engineering@wupix.com. Appreciate ECLM in the subject, and I'll try to get you a pre-release version. But yeah, that is my talk, and I hope you like what you see, and we'll grow it into something better. So.
Any questions? How far are you from being able to load and use Quick Lisp and these libraries?
Maybe we should bring Zach in to help me answer that. I honestly don't know. So right now it uses ASDF ASDF in the sense of, well, I've built it in. So I wouldn't recommend pulling in a new ASDF, but if you have a directory that you can symbolically link some ASD files to, it can read those and use that. I'd like to do something with Quick Lisp, but it's just not there yet. So.
Yeah, what I was thinking was a lot of libraries have little backends where they go hash plus Lispworks, hash plus ACL, etc. down the line, so they have some sort of uniform way of addressing VFLI, sockets, you name it. Somebody would have to go through all of those going hash plus Mocl.
Yeah. So definitely where libraries become implementation dependent, there's a good chance that it would have to be implementation dependent on Mocl as well. I've already pushed out some patches to some popular things, trivial features, maybe trivial something else. I have a usocket somewhere.
Can you do us a favour? Can you keep a list of all the things, places you have to go to? Because that then gives us a way of saying, I'm a new kid on the block, this is what I've got to do. Or possibly even, there are too many places to go to, we should reduce it.
Yes.
Be a really useful community resource.
Yes, I should do that, and I hope to have adequate, resources all around once I get it out there. So.
Would that be possible to develop interactively, where, for example, iPhone attached to my laptop and I want to execute the code directly on the iPhone while I debug my program?
Yeah, that would be very nice. I want that too. Yeah, not there yet. Yep.
The application that you produce with Mocl, can they be pushed to the App Store, or do I need to jailbreak my device?
No, they can be pushed. That's a major part of my design focus, is to make sure there's zero reason why you could get rejected from the App Store.
How much of ANSI is not supported, or what are the fields where ANSI compliance will not be achieved?
One missing piece is eval. To do so, I would have to at least embed a Lisp interpreter, and I'm not even sure if there's really any sort of App Store compliant reason to do that. Seeing as any Lisp code you have could have just been compiled ahead of time. If you're doing it at runtime, that may technically run afoul of policies. Actually, I'm going to be at Apple's WWDC conference here pretty quick, and I'm hoping to kind of ask questions about where that dividing line is. Yeah, that's one eval. Maybe some generic function, like I only have standard method combination, or stuff that for typical libraries I haven't really run into problems with. So my main goal has just to be that it's useful and it works. The good commonly used parts are there. Other stuff, maybe not.
When you wrote a compiler, did you build on any existing technologies or any existing code, or did you really start from scratch?
Definitely not from scratch. This is one of the nice things about Lisp, is that there's such a rich history of code out there. You know, I mean, I've got loop in there. I think it dates back to symbolics code. So I've pulled in as much open source as I can, and where I couldn't, there's quite a bit of original code. So.
What about access to user interface stuff on the Objective-C side?
Sorry, can you repeat that?
User interface, when you are accessing forms or not on the iOS side, can you write it in a Lisp way, or you have to go to Objective-C or Java?
Right now you have to use Objective-C or Java. That's not the worst thing though, because their tools are actually quite good. They have drag and drop user interface designers. So for instance, those form fields I had on both iOS and Android, inside their tools I was able to just like drag, okay, give me a text box, and design it that way. So I feel like this is the low-hanging fruit approach to work within the existing tools, and it also keeps you current. I'm not having to always play catch-up against an API or something like that. So yeah, that's the approach right now.
Question is, how much interest do you see in this as this community? Are they not very deep? How do you study for how it grows in this sport? How do you have to make money out of it?
All great questions, and I kind of wish I knew, more myself. I get quite a number of emails, so I feel like people are at least curious about it. As to what the future holds for it, it's hard to say. Common Lisp is a pretty niche market, and my real goal, my real hope is that if we can get these new tools and get some cool factor in the Common Lisp, we could really grow it community-wise. And in that sense, sort of everyone benefits, but.
Can you also compile standard language or just for mobile?
So internally, I often target OS X. I haven't really proved that out as an official target, so it's not really there. But in terms of generating C, that C code is very portable, so other targets are possible. And that's kind of part of the philosophy, is that because mobile devices are so varied, we'd like to have a lot of flexibility in terms of being able to reach them. And as other platforms become important, I'll go after them.
In Android, you target the Dalvik machine?
Yeah. In a way. What I do is JNI under Dalvik. So it's fully compiled by a C compiler. Actually, it could be GCC or Clang. But then there are bindings that let them talk to the Java world. And then on the Java side, I put Mocl also generates Java code that then talks back to the Mocl C code that it generates. If that makes sense.
Did you put some work into being able to embed C code inside this code, or is this?
That would be nice.
Okay.
somebody.
Besides user interface, what about calls to APIs, platform APIs, so sensors and...
Yeah, that's probably one of my biggest areas that I want to go to soon that I don't really have well handled now. Yeah. Looks like we're out of questions, so.
Great. Thanks a lot.